something like that.
Ladies and gentlemen, I have with me live in studio as of January 29th, 1988, our inventor of the N machine, Bruce DePalma, the guest who has caused me more problems than any other guest I've ever had.
It's nice to really be appreciated, and I'm certainly happy to be back after, I don't know how long it's been.
It's been
a while.
Maybe, it was definitely last year sometime. I think you were here.
Well, what I do remember is this about exactly 3 years from our first encounter, and when I was on KPFA, and you played that tape down here and then invited me down. I remember sitting right here in front of this desk, and it was a night when Diane wasn't helping us, and it's sort of like a cycle, a completion. And what's, I think, important...
Okay, if you hear some difficulty going on, Diane isn't here helping us again.
Yeah, we are a little bit moving around here. But nevertheless...
we're also being videoed.
Yeah, we have television present tonight. So... prior to this time, I'd always been sort of on the way to or trying to put together an N machine, and was more or less hyping the whole idea of free energy. But now we've completed our project, and I wrote Roy a few weeks back, and I said, okay.
Oh, wait, I want to stop right here
Go
at
ahead.
this point, because we've gotten in the last few months, we've gotten quite a few new listeners. So there's a respectable percentage of the audience who never heard of you and don't know what it is that you do that makes you be here. So just, not like a half an hour, but kind of quick. You are Bruce DePalma. You are the inventor of the N machine.
Yes, I'm Bruce DePalma. I'm a physicist. I'm the inventor of the N machine. And the N machine is a name for a way to release energy from space. It's by taking electricity directly out of a magnet. The idea was originally discovered by Michael Faraday in 1831, and he discovered that if he took a magnet and he spun the magnet around its axis so that the magnetic lines of force were parallel to the axis of rotation. That is to say, if you took a cylindrical bar magnet, for instance, one end north and the other end south, and you just rotated this around its long axis, or the line going through the poles from the north to the south, and if you rotated a metallic magnet that conducted electricity, and you put a wire on the outside of the magnet, and you put another wire on the axle that was supporting the magnet, you would get electricity. And Michael Faraday discovered this. And Michael Faraday, for those who don't know who he is a very famous...
he's the George Washington of electricity.
Yes, you see, I was going to say the fame always comes later, but he was the guy that put together the first electrical generator. And when somebody said to him, "What's that good for?" he said, "Well, someday you're going to collect taxes from it." But Faraday was mainly interested in science, and he never got into anything commercial. So he made the first electrical generators, but he didn't ever make money from consulting or...
Okay, so you have an amplification of Faraday's work, or is it just is it a logical continuation of Faraday?
Well, you could say, if you use the word amplification in the sense that you're magnifying something, sure, it's just like that. I've just taken his initial little experiment and I've amplified it. I've multiplied it by a factor of 10 or 12 or 20 times larger. And with the modern techniques of removing current and liquid metal conductors and things like that, I've taken the old idea and I've put it in a modern context that I feel is going to be very, very useful for society, because the very interesting thing about this effect of taking electricity right out of a rotating magnet is that in terms of what we know as drag, or the work or energy we have to do to create a certain amount of electrical work or energy, for this kind of electrical generation you don't have to do as much work as you would have to in a normal electrical generator. And the factor is about I would say around 4 times. They say you would have to do about a quarter of as much work as you need for a normal generator to get the same amount of electrical power out of it. And all I did was, firstly, since I went to a prestigious engineering school in New England called MIT, and at MIT all the thoughts about electricity are supposed to be known and categorized in terms of equations. They never even taught.
It's sort of the George Washington of technical colleges.
Yeah, they would never even mention a thing like a rotor without a stator, see. So I was never even acquainted with this idea in college. So later in my thinking, but my thinking had to be stimulated by the needs of the planet. My thinking, I started meditating on magnets and rotation, and I dreamed up this thought that you could extract electricity directly out of a magnet. And I later made a little model and tried it. And then I was told by someone when I sent out a paper and I tried to tell all my friends about it, and someone said, well, Faraday had discovered that in 1831. Well, sure, but no one since 1831, or even Faraday, had ever tried to generate a useful amount of electricity from this, useful enough in the sense that you could test it to see whether you had to do the same amount of work to get that amount of electricity that you had to do with a normal machine, which depended on the motion of a wire past a magnet, which is a two-piece.
So what you did sort of is you landed in a jet plane, and the people said, "Oh, well," in a place where it didn't have any planes, and then some guy said, "Oh, the Wright brothers did that in 1908."
Well, they did do it, but they didn't test it in the way that I tested it. They got the effect, but they never tried to see whether they could make a big enough machine to get enough voltage out of it or power enough to test and see whether it was exactly the same kind of a generator as the normal generators. And the normal generators we use are based on another law discovered by Faraday, which is called the law of induction. And that simply says that if you have a magnet and a copper wire, as we all have seen in high school, that if you move the wire through the magnetic field of the magnet or near one of the poles, and if you put a voltmeter across the ends of the wire, you get a voltage. And all of the machines we use in our cars and our homes and the generating plants use big drums with wires going around on those drums past magnets, and the voltage is picked up by sliding contacts. And this is a conventional electrical machine. It uses two parts, a stationary magnet and a rotating drum of wires. The thing that I worked on only uses one part. It just uses a single magnet. The magnet's rotated like a wiener on a stick, and you put a contact on the outside of the magnet and one on the axle, and you take the electricity directly from the magnet itself. So this principle, although known, had produced such a tiny amount of electricity in the days when Faraday discovered it that it took modern magnetism, modern magnetic materials and engineering to raise the level of voltage of this machine so that it could become useful, and so that we could really test it and see whether or not it actually was a superior electrical generator. And so that's what I've been working on. The project that I've completed has been to build a big one of these machines.
Now, this is the N machine, and it delivers electricity at a more efficient rate than the normal electricity deliverer.
That's right.
Okay, now what's the effect? What would be the effect of this machine? What does this machine do that makes it so great besides the physical operation of it?
Well, it has a lot of things which are interesting about it, but I would say the two things that make it so great are, one, it's so simple. Normal electrical machines use two parts, a rotor and a stator. That is a part that turns and a part that sits still. This machine only uses a rotor. Well, that's all there is to it. And the other part of it is that this simplicity, well, it allows you to do some interesting things, but the simplicity is connected also with the fact that you get less drag than you get from a normal machine. So the two outstanding features are that it has less drag, I would say a quarter to a fifth, for the same amount of power as a normal electrical induction machine, and also that it's very simple and it's much less complex to make than a conventional electrical generator.
So you have a machine that's is it less complex than a nuclear power plant?
Oh yes, far less complex. You know, the interesting thing about this whole conversation is, and coming back to cycles, is that I had been trying to interest the scientific community, the industrial community, my former professor friends at MIT, in this idea for a long time. And we had made several machines starting from 1978, which did show that the effect was operative. That is to say, you could extract power from this machine with less drag than you would have from a normal generator. And in the early days of this, all of my former associates, my friends, all my professional contacts, all, when they found out what I was doing, they just turned away from me, and I had no relationship anymore to any kind of professional societies, because I didn't realize at the time that the idea of producing more energy from something than you put in was such a I don't like to use the word mind-boggling or threatening, but those are the things that go through my mind. But you see, the difference between me and what you might call a conventional scientist is that I feel that the primary things that we want to understand in this world are the basic phenomena themselves. If I find that a magnet puts out electricity, and I can use this effect in some machine that's helpful for society, then I don't need 10 theories to help me understand this or anything. And even if I had the 10 theories, I'm not at all certain whether I would know more about it than I knew if I simply just took the electricity out of it in the first place. So this leads us into, you see, this, where we are right here is a juncture where we can pick this conversation up and let it go in several ways. I think the one that's easiest to understand is that 3 years ago I started out here at this microphone, and I had produced several N machines, and I call it N with a capital N because it's the N in science means a lot, many levels, the nth degree, and I always felt that many things beyond my comprehension would result from the use of this machine. So that's why I called it the N machine. So I started out here, and I had been trying for at least 7 years to get substantial funding and financing to help me do this. And I'm coming from a background in research and development. I was a laboratory manager. I was a professor at MIT. I spent millions of dollars. I managed large numbers of people. I was always successful at the things I did. And I knew how much money it would take to convert an idea or an inspiration. You know, you got the idea that you're going to make a picture in a minute, like a Polaroid camera, but how many millions of dollars do you have to spend so that you can go down to Woolworths and pick one up, you know, in a bag? So I know how these things operate, and I knew that I needed a substantial backing in order to consummate this project. And so I was on the radio, and I was talking about free energy and its possibilities, and sitting right here, and this started a development. First of all, it created a lot of havoc down at KPFK, and a lot of people started writing to me, one of whom was a listener to this station and had been for many years, and he was a wealthy millionaire liberal, over 60 years old. And as it eventually turned out, if we wrote many letters back and forth, he agreed to back this project, which the one I've just completed, which has been running for the last 2.5 years. And I hope that he's listening right now. Of course, he's always wanted to remain in the background and never wanted his name mentioned in connection with this project, but he is over 60 years old, and now he's in the hospital, and he's had some kind of emphysema or some kind of lung trouble, and also some kind of psychiatric or mental problems too. And that is hard for us to deal with in two ways. One, if someone's doing something which I think is really good for society, and that is supporting the efforts of my group, and I'll talk a little bit about that later, in consummating this machine, I think that's a wonderful act, and it's helping so many millions of people around this planet that it just can't even be counted for the things that have occurred and all the information that's been generated out of all the work that we've done in the last 2.5 years. And so for a person that wants to remain anonymous, and yet not, by remaining anonymous, he's cut off from all the goodwill and all of the good vibrations that come from the gratitude and the friendliness that goes along with backing something like this, because this is truly a revolutionary activity. So I don't know how the listeners might feel about this, but they should, if they could, or if they would, or if they want to, they should, maybe send a little energy this way. And I can't tell you, power level in our society is directly connected to the energy companies. Energy is the basic commodity, and from that all else comes. So although we live in a country where we feel we're fairly comfortable, there are forces acting around us in subtle ways which are affecting our future and the future of our children. And it's places like this that fortunately exist where we can bring these things out. So the thing I'm trying to say is that the major company which we were dealing with, which was a company named Micro Cogen in San Diego, was put out of business as of last Friday. And this is not a small company. It's about $126 million. And they make what they call cogeneration systems. And this is an idea where you have an industrial process and you have heat or gas as a byproduct, and you convert that heat or that gas to electricity, and that electricity that you generate can reduce your overall electric bill.
And that has been a huge percentage of the electricity additions being used in California that the gas and electric company doesn't want to talk about.
They don't even.
But cogeneration has been the major contributor to new power in at least California.
That's right. And so what we were linking up with was the major cogeneration company in Southern California, Microcogen Systems, which did make a system which was a gas-powered system. In San Diego, when you pay your 15 cents per kilowatt hour for your electricity, what you're really doing is paying off the Diablo, that is the San Onofre.
San Onofre.
You're paying off this, you're paying off the nuclear power plant right up the coast, and you have an artificially elevated electrical cost as opposed to, say, 3 cents a kilowatt hour, which we might pay up here. Now, what I'm trying to say is what this company...
Over 90% efficient?
Yeah, this little machine. What this machine did was they took the gas, which is cheap.
Nukes are 3% efficient.
Yeah, a total blur. They would take the gas, which is available in San Diego or Southern California, and burn that in a gas engine and drive an electrical generator with it. And they've enclosed this thing in a hermetically sealed box, and it's quiet and it's soundproof and it operates without much maintenance. And this box will produce 30 kilowatts of electricity at a cheaper rate than the electrical company could sell you the 30 kilowatts of electricity. And they were in business selling these units up until a week ago. And what happened was, now I don't, of course, who knows, what fine wheels turn in this
looks
society.
Sort of like a Xerox machine.
Yeah, I don't know what fine wheels turn in this company, but in this society. But what happened was there's a new law in California, which I have a copy of, which I'm searching out here, that says that any time you install a electrical generation system in your property, and that could mean even if you put in a Honda generator to, I'm trying to find my glasses here, I put them down, so, oh, here they are. Even if you put in a Honda generator, you have to, I'm reading you now, Assembly Bill introduced by Assembly Member Floyd. This is February 14th, 1986. And what this bill grew out of is that somebody got electrocuted because they were working on a power line which was connected to some country club or some place which had an emergency generator, and when the main power went off, the emergency generator kicked in, and the guy that was working on the lines forgot to short things out, and he got electrocuted, not knowing that the emergency set had kicked in. And this is supposedly it says electrical hazard to utility workers. And they talked about when the utility workers disrupted the power to the lodge's emergency generator was started, but the knife switches weren't operated correctly. So anyway, they put a law in which says that any time you put a generator in, you have to get... This bill would require any portable electrical generator that is capable of being connected temporarily to a customer's electrical system, which is normally supplied by an electrical corporation, to be connected only after opening the customer's main switch so as to isolate the customer's electrical system from that of the electrical corporation or state or local agency. What this says is if you have a home generator, you have to fix it up so that when you hook it into your house, you have to disconnect your house from the external utility. And that's part of the electrical code. You don't need to have an extra law to do that. This is pretty obvious. And if you also tried to run the whole housing development you're in from your electrical generator, you'd find that you couldn't do that either. So you have to have this kind of transfer switch, and they're all in there by law. But now here comes the part which is relating to the demise of micro cogen. As part of this law, it says, 1. Generators. 2. Any owner, renter, or lessee who possesses an electrical generator shall notify the utility of the presence of the generator on the premises. Any person who violates sections 25882 or 2583 inclusive is guilty of a misdemeanor and subject to a fine of not more than $500 or not more than 6 years imprisonment. And B, for the purposes of this section, person shall not include public agencies, officers, or employees of public agencies or public utilities. So what this says is that any private person who puts a generator on his premises has to notify the power company, and all the people that are exempt are public agencies, officers, or employees of public agencies or public utilities. Now, the way this was used to put microcogen out of business was that when they install their units in all their customers' places, they had a pro forma which went along with the unit, which detailed about how much power savings the installation of this unit would give them. And then this law went through, and the electric company came to them and said, not only do you have to give us the plans of every one of these installations, but you have to tell us where they are. And so once they got the addresses of the customers of microcogen, they went around to the customers one by one, and they renegotiated the electric rates with them on an individual basis so that they were low enough so that the microcogen unit was no longer required. And after a month of this, the company ceased existence. See, now this is how the California utilities feel about private power generation.
They should microcogen should make a fortune off of this law.
Well, I don't know.
Yes, because they could sell a machine that would cut your electrical bills in half and more, and the machine would only cost like $100 or $500. See, what you do is you get it's a nice looking machine. Mm-hmm. And it looks sort of like a primitive Xerox. So you just get the shell of the machine. You don't have to have any generator. You get this fake shell, install it in the building, call the electric company, say, I got this machine, and I don't need your service anymore. The electrical company will come and say, we'll cut our bill in half if you get rid of this machine. And then you
realize how illegal that is. You see, if they make special rates for certain customers, then what about all the other customers? The only reason this
we pay more.
Well, right, overall you pay more so that certain pay less. And the thing is, the people who I've gotten this information to are too frightened for me to tell you who they are. But I'm not frightened of passing this on because all the other electric customers down there in San Diego ought to know about this because it's discrimination.
Assembly
it's restraint
Bill
of trade.
3222. February 14th, 1986, introduced by Assembly Member Floyd, not Pink Floyd. So, isn't it illegal for the electrical company to? I mean, legally, not morally, but is it legal for the electrical company to make these special deals?
Of course it is. Of course it is. And the thing is, what it comes down to is you are then in the position where you can sue San Diego Gas and Electric if you can afford to. You see? And so this is very important, folks. You see, because what this is basically saying is that there is no accommodation with the power companies. Power companies are run by actuaries and accountants. They have no ability to generate new ideas. They don't build new kinds of generators. They just put together blocks of nuclear reactors and steam plants, and they have their computers and their load-sharing ideas, and they try to maximize the profit. And the fact is, the only way that they can do this is if they're their only show in town. If they have no competition, they can do things like this. And so it seemed to me that the dinosaurs, I call them the power companies, I would have thought they were so dinosauric that they wouldn't have done a thing like this to eliminate one of the major cogeneration companies. But that, I guess, is not true. I guess since they have so much time on their hands, because I'm sure there's no thought involved in just collecting money from people's meters, that they can just think about how to get rid of the competition. And this is just exactly how John D. Rockefeller eliminated the competition when he set up the Standard Oil Company of New Jersey. You see, you undersell them until they go out of business. And this is a monopoly, like a power company is in a position where it can undersell a private power company and put them out of business. Now, whether or not that's the prerogative of monopoly, legally, I'm not certain. You see, but this is what's happening. And the thing is, I don't care a whit about the San Diego Gas and Electric Company. I am interested in the cost of power to the consumer. You see, this is really important. And all right, but okay, let me just throw something else in here at this point. So we're talking about power. I have a letter here from the Department of Energy, Washington, D.C., December 18, 1967. And this is to a Dr. Clark, who is another worker in the field of free energy, and he tries to do what he can to help people understand things along the lines at which he understands them. But nevertheless, this letter is fairly clear. It says, "Dear Dr. Clark, your note of November 23, 1987 to President Reagan attached to a copy of my letter to you of November 16, 1987, declining the opportunity to attend your proposed demonstration of an over-unity electrical generator was referred to my office for a reply. In your note, you asked why the Department of Energy was not vitally interested in the generation of energy. The Department of Energy is vitally interested in the development of a wide range of energy generation technologies. It has been our experience, however, that the principles on which the over-unity electrical generator, and this is in quotes, are based defy the laws of physics and are not considered a promising area for current development." And my comment at this point is that I am so touched that the United States government and the Department of Energy is supporting the laws of physics. I think that that's just what the laws of physics need to make sure that they last and endure, don't you think?
Yes, the sacred laws of physics handed down on Mount Whitney.
That's right. This is signed by John J. Brogan, Director, Energy Utilization Research, Conservation and Renewable Energy. And of course, they also suggest here, however, if you feel the technology merits governmental interest, the Energy Related Inventions Program, which was specifically established to evaluate and assist in the development of promising energy-related concepts and inventions, may be of interest to you. Under this program, the National Bureau of Standards evaluates invention ideas to determine their technical feasibility and marketability and the potential for significant energy conservation or supply improvements.
They're the ones that, the Department of Standards are the ones that took Joseph Newman's machine. Right. They grounded it, which it wasn't supposed to be grounded, and the specs very clearly indicated that. They grounded it, and then they tested it, and it didn't test out like Newman said. And of course, and so now there's the official word on the Newman machine that it doesn't work, and it's referred back to the Bureau of Standards.
That's
right.
It's
a terrible tangle to be able to untangle.
Well, it's amongst those of us in the field, it's known as the tar pit. And the tar pit, you put one foot in, and you lift that up, and the other foot goes down a little bit more, and
the exact same thing was done, I just found out in the last couple of weeks, with one of our favorite herbs, echinacea, which is a blood cleanser. and it's been used in America for thousands of years. And I found out, I thought it was a big secret, and it turned out that this herb was very, very popular around the turn of the century, very generally, popularly known and used. And what happened is that the AMA guys got microscopes, and they took echinacea, which it's a herb that it like boosts your immune system, but it doesn't have any poisons in it. Anyway, they took the echinacea and they cut it down into its component elements, and they found that not one element was antibiotic. And so therefore they said it couldn't work, and therefore what happened is it disappeared overnight. And you had the empirical validity of something, but because it didn't fit in with the principles that they had established at that time, they said it doesn't exist.
Well, I'm certain that you can take any very valuable compound like aspirin and reduce it to its atoms, and you won't be able to tell what it does either. So there's always a way.
Oh, it makes you healthy. I'm reading in the paper. I take hundreds of them, armfuls, truckloads.
All right. So
sure.
Beyond all this, let's go on to more positive levels.
There are positive things.
Yes. The other thing I wanted to talk about tonight was I'd like to tell the listener something about just exactly my work, what it's been, and how I've accomplished it. And as I said before, we spent quite a lot of money. And what have we produced? We've produced an N machine which can produce at least 100 kilowatts of power, has at least 3 times more output power than the input, and visibly demonstrates overall, including all the inefficiencies and everything else in the system, that you can put more power in a pair of wires than you can get out of another power. I mean, you can get more power out of one set of wires, which is being powered by another set of wires, which is putting less power in. It's a very, very interesting phenomenon. So we have completed our machine, and I just want to talk a little bit about just how this happened. I do have, in Santa Barbara, I have a DePalma Energy Corporation. I also have a DePalma Institute for nonprofit researches in free energy and the dissemination of information that has been dug up and researched by us. In terms of my researches, I have had to pursue my researches on the same level as KPFK operates its radio station. My people are volunteers. I've had as many as a dozen at a time or so, but there's a whole lot many more of that who've contributed freely of their time and resources. And the monies that we've spent have been spent on materials and machining operations and other technical things that we couldn't accomplish in our own scope. And so consequently, if any of you know how much it costs to operate a company, usually you have a certain what's called overhead ratio. And this means that if you have a man who comes in and does work which you pay him $20 an hour for, you charge to the job anywhere from 5 or 10 or 15 times that amount of money, because this extra amount has to pay for your building, your plant, your overhead, your insurance, your paper, your secretaries, your computers, your parts department, and all the other facilities. Now, when I started in the government R&D business, the company that I worked for used to hit the panic button when the overhead rate went more than 2.8 times the direct labor rate. Now, in the enlightened age we live on, the aircraft companies operated 15 times the direct labor rate, and so you get the $600 toilet seat phenomena and the $100 screwdrivers. So nevertheless, in a company where you don't have any overhead, then all your money can go directly into operations. And so we've had, because of the nature of my work, which is to produce reports and show people what I'm doing and demonstrate my machines and do these things for the public interest, people have worked for me. And I know they name on the air here all the your contributors, they call up and give you $40, and you say, well, so-and-so called in from Anaheim. I could mention a lot of names. I don't know whether it's appropriate, but a lot of people have helped us. And so that's how we accomplished it.
It wouldn't be inappropriate if you want to throw in.
Well, I think of people like Josh and Ed and Bruce, and we have Mark and Richard down here doing television tonight, and Roger, and God, it goes on and on. But these people have given of their total existence, and the reason that good technical people are out in the world is twofold. I think, first of all, we're in a situation where a lot of people have been laid off. For instance, Vandenberg has been cut back, and the shuttle isn't going to go there anymore. So there's a lot of technical places which have closed down. There are a lot of technical people with nothing to do. And then there's another sort of subgroup of the technical people that are out there who are committed to peace and will not work on military bombs or aircraft or anything like that. And those are the people who have given their efforts to me. That the ones who will not involve, and I'm the same way myself, I will not work on offensive weapon systems. I worked on defensive systems, but I never worked on, and I wouldn't work on, anything destructive. So this has been an enormous contribution, and they put their stamp on the work that's produced, and it's a wonderful thing. So anyway, we've had to do some very difficult things. Our machine uses permanent magnets, and we've had to learn how to work with the most powerful permanent magnet material in the world, which is presently available. It's called neodymium iron boron, and it's a magnetic alloy that was developed about 5 years ago, now come into commercial existence. It costs about $55 a pound. We used 400 pieces in hexagons, 2 inches across and 1 inch thick, because this size is the largest piece that can be magnetized. Because this stuff is so difficult to magnetize, it takes one humongous magnetizer. And consequently, anything that you build larger than the largest pieces that can be made, which, as I say, 1 inch thick and 2 inches across, have to be assembled out of the smaller pieces. So we made a rotor which is 13 inches in diameter and 8 3/8 inches thick. And we assembled each one of these out of 200 of these neodymium iron boron, and it's mostly iron, just a sprinkling of neodymium. It's a rare earth and a little boron. And these hexagons repel each other tremendously, because when you try to assemble a large magnet out of small magnets, you build up the magnetic energy concentration, and this makes the structure try to repel itself. So we had to build special jigs and develop adhesives and ways to stick these hexagons together, which took in itself an enormous amount of time. And then once having assembled these rotors, you have the problem of moving this object, which now weighs 800 pounds and is an intensely magnetic piece, which, if it ever sticks to anything, you have to pry it off with wood. You can't use anything metal. And every time you move it through a machine shop, you have to carefully see how you're moving things so it never gets near enough anything to it's just a terribly dangerous thing to do. And all the operations, it's very, very, the magnetism, and after you get finished working on a lathe or a milling machine with this, on this rotor, you have to demagnetize the lathe and the milling machine. And so we had to do things like they used to demagnetize ships. You wrap heavy cables around these big machines and take a battery and go zap, zap, and we had a magnetometer on them to see when the magnetism would get down to normal, because the machinists would go crazy because all the machines would get magnetized. See, so, people think that an end machine is a simple machine. Sure, it's a simple rotating magnet, but the assembly of a large rotating magnet for many small rotating ones is quite a formidable task, and took us a couple of models and trial apparatus and a couple of experimental jigs, and we finally mastered it. And it was one of the reasons it took us a lot longer to do this job than we thought, because if it hadn't been magnetized, it would have been fairly easy. But when you have a machine that's so powerfully magnetic it lifts tools off the floor and they go into orbit, and you can't bring it near anything, and you have to be very careful how you move it. You always have to carry it in a wooden truck so it doesn't stick to the bed and stuff like that. This takes a lot of consideration.
Sounds to me like you spend a lot of time prying things away.
Oh my God, it was incredible. And when you're doing something like this is a research and development effort. Now, I told you that I used to manage laboratories and I spent millions of dollars, and I have. And I always worked for companies where if I made a mistake or ordered the wrong part or we went up the wrong alley, they would always say, well, yeah, we'll charge it to the job, and that's part of the thing. But when you're doing a project which is like a machine that produces more energy than it consumes, which in itself is somewhat, what should I say, controversial.
Controversial.
And half the people around you are scared to come near you, and they don't want to even touch you. And the thing is, what I'm saying is I only have a certain amount of money, and I can't afford to make any mistakes, because if I do, then I lose it. You see, my backer's only good for so much, and if I waste that, I've shot it. So that's what makes the planning of this thing so hard, because you've got to plan. The interesting thing about doing something that's never been done before is that if you're planning an operation which might take 6 months or a year to come to fruition in terms of all the machining, you've got to make sure that what comes out at the end, you haven't thought up any improvements between the time you started the thing and the time it's finished, and that really strains your brain. I mean, you have to really think everything out, so that if it takes 6 months to machine the thing, then you haven't thought up any improvements in the meantime, which would make you want to change it. Well, that took a lot of strain. So it was a leading edge type thing where if we made any terribly expensive mistakes, we were finished. So, but nevertheless, we did finish, we did complete, we were successful, it did work, and now we're in a situation where we've written a report which the listeners can write to me in Santa Barbara, and I'll give you my address. We'll send you a report on what we've done. And I can start, I can show this to people. For a long time, people were calling me, and they would say they want to come and see me. And I'm really sorry for all the times I've held off, turned down, and obstructed those who wanted to come and see me because I wasn't finished with a job. But I don't know how I can quite explain this to you, but if you're in the middle of your sculpture or your painting or your artwork or your job or whatever it is, you don't want to have anybody take a look at it until you're finished with it and you're satisfied that it's what you want it to be. And, we not only doing something which most people don't think is possible to do. I've had engineers look at this thing and say, well, that's impossible. You can't generate electricity that way. And I said, well, here it is. And so not only do we generate electricity, we generate quite a bit of it. And so you're doing something which is very, very hard for many people trained in a conventional way to accept, you see. So I don't want to show anything to anybody which can be misinterpreted and where people can go away feeling that they haven't been given all the information they want. And the only way that can happen is if I'm allowed to finish what I started and the thing is ready to be shown, which is the reason I'm talking on the radio tonight about this subject. Now, that's what I've done. I've finished this machine off in the United States, and it's now available for those who want to use this kind of a machine to do the next great act, which is going to transform our society, and that is to produce the self-running engine. Now, I originally started this project to produce a generator that produced more energy than it consumed, and I thought that just simply doing that would be enough. I guess I was wrong, because what I found out, and what's clear from the way the electric company behaves, is they're not interested in any contributions to their electric power system. I mean, if you buy electricity from them, they'll sell it to you at the local home rate, and if you sell it to them, they'll buy it from you at the industrial rate, which may be 1/10 of that. So, if you're going to seriously consider electricity as a resource that you want to grow on your own, back in the 60s when we were all getting turned on and we were discovering that we could grow our own food and we could pump the water out of the ground and we could live out in the country and it'd be smog-free. We never escaped the electric power cord, the gasoline station, the oil tank. We never quite figured out how to grow that kind of stuff. Well, basically what this self-running machine means is that energy as a resource can be homegrown, and that you can be independent of electric power grids and meters. Now, as I said, when I started this project, I was simply trying to make an engine or a generator that produced 3 or 4 times more than it took in. When I got to the end of the project, I found all the people that came to see me wanted to see something where the output was great enough so you could hook it up back to the input and it would run itself. And so the scope of my project has been enlarged considerably, and so, to say the least. So
it sounds like a snake who eats its tail. Right?
Well, maybe. It's maybe a solar-powered snake, and it grew as it ate so that the circle stayed the same size, yet it was satisfied continuously. But nevertheless, I find that the thing that people are interested in mainly is the self-running engine. And being that I'm a scientist, the way I work is that I don't try to do too much at once. And I've understood all along that if you want to make a self-running machine, you first have to have a generator that produces more than it consumes. It's easy to make the motor part. It's not so easy to make the generator part. And so anybody that wants to get into research and development on self-running machines has to begin with the kind of thing that I've built, which is an end machine that can produce up to 12 volts, 10,000 amperes. It's 120,000 watts. So this is a considerable amount of power. The enlargement of the project to incorporate the idea of a self-running engine puts me into a totally different reality. And at this point, I'd like to talk about what the foreigners are doing and what I would like to be able to do. Do you want to take a break now, or do you want to ask me any questions or something, and we can come back?
You don't mean foreigners are getting this technology?
Yes,
for us.
Well, I would say they're about even with us right now, and I'm terribly disappointed in a lot of things that we're doing, but let's chat about that in a moment, okay?
Okay, we'll take a break. This is KPFK Los Angeles. We are on the air with Bruce DePalma, live as of January 29th, 1988. Bruce DePalma, the inventor of the N machine, and we'll be back after a short break. We're Bruce DePalma. We are talking about foreigners.
Yes, foreigners.
You mean foreigners getting our machine?
Well, the foreigners, evidently, they're in a little bit different situation than we are. Right in front of me, I have a call for papers for the International Congress on Relativity and Gravitation. This is Munich, West Germany, 22-24 April 1988. Now, this conference is a conference where the most scientific discussions of, it says gravity and relativity and gravitation. Well, underneath that is free energy and free energy machines. And what it has to do with gravity and relativity is this, that in the Einstein theory of relativity, the only important parameter is the relative motion of one object to another. The relative motion. It doesn't make any difference whether A moves past B or B moves past A, the motions are, if the relative motions are the same, whether it's B moving or A moving, it's an equivalent situation. This conference on relativity and gravitation considers the idea that relativity is invalid, and there are many experiments which are going to be talked about having to do with the measurement of things like the velocity of light and various effects in electricity and magnetism. But what it all boils down to is this. It seems so very, very simple when somebody says the only important thing is the relative position of A versus B, and it doesn't make any difference whether B moves relative to A or A moves relative to B. Now, does that apply in this situation? If I have a magnet and a wire, is it exactly the same situation if I move the magnet past the wire, or if I keep the magnet still and move the wire past the magnet? Now, according to relativity, these situations are entirely equivalent because moving the wire relative to the magnet is exactly equivalent to moving the magnet relative to the wire. However, if relativity is not valid, then a different electrical effect should result, and does result, if you move the magnet past the wire as opposed to moving the wire past the magnet. And that's one of the effects that's going to be discussed at this conference. And this idea of relative motion being invalid, and that there's something about the universe which implies that there may be a thing which we could call absolute motion, motion with respect to the universe itself, which has been measured by radio noise experiments from high-flying jet aircraft, where they, through the velocity of the aircraft, were able to show that flying in one direction they got more noise than flying. That flying, the noise picked up in the direction of flight was greater than that away, so that there was not an isotropic radiation field of what you might call galactic noise, that you could actually move in relation to this field and actually pick up more energy if you moved into it. So these experiments have been performed, and they're very, very profound, because all the electrical machines that are made operate on the fact that it doesn't make any difference whether the wire moves past the magnet or the magnet moves past the wire. And so all I can do is introduce this very interesting thought to those of you who like to design electrical machines, that the two situations may not be equivalent, and that's one of the subjects discussed at this conference. All right, that's in Germany, and I might also add that I get on the average of 2 calls from Germany a week from people who have made N machines, and the most recent one being from a Dr. Kristowski in Dusseldorf, who got 3.2 to 1 last week and is sending me some report, and a magazine in Munich called Raum und Zeit, Space and Time, is devoting their February issue to the N machine, and the report of the machine which we constructed in Santa Barbara, as well as the German machines, are all going to be discussed there. It's in German. I don't know whether, there are people who can get a copy of that periodical, but that's the subject for February. Now, coming up in June 25th, June 28th, 1988, the 3rd International New Energy Technology Symposium Exhibition. This is put on by the Planetary Association for Clean Energy in Hull, Quebec. Now, I guess the easiest way for me to give you the way to track this one down is give you their telephone number. If you want to call about this conference, you can call area code 819-777-9696. That's 819-777-9696. And that's coming up in June. Now, the final thing I want to say about the foreigners is that I have the most recent paper here from Paramahamsa Tiwari. And Tiwari is a member of the Department of Atomic Energy Nuclear Power Board, Bombay, India. His paper is Electrical Power Generation from Absolute Vacuum, and this paper has been published in the, let me find it here, it's the East Asia, the Indian and Eastern Engineer. This is a publication, the Indian and Eastern Engineer, and I think this was for January. So there's been an article about Tawari's work in India, and this man is receiving the kind of support that I ought to be getting from the Nuclear Power Board in the Indian government. And this is official work going on in a third world country. And he talks about how he's going to connect his end machine to a certain kind of a motor called a Faraday disc and make a self-running engine. Exactly what I would like to do here in America. But as I said earlier, this is a fairly major project, and we'll have to get, we're at a juncture in our work now. We've produced a machine, and if I could get an order for one or two or three, I could be all right. Or if somebody would come in and want to donate some money to continue this research, it would be wonderful. But we are at that juncture point now, and I guess that's a good time to open up the phones, or you want to...
Oh, no, bring it. Now we can all appreciate the great work Diane does to help us avoid this.
Yeah, we got everything ready.
If you want to call and talk to Bruce, this is KPFK Los Angeles, by the way, and we are on the air with Bruce DePalma live as of January 29th, 1988. And if you want to talk with Bruce, then call us at area code 818-985-5735, 985-5735, or 985-KPFK. We will answer your phone on the air, so if you get a ring, just let it keep ringing, and we'll answer it when you're on the air. Unfortunately, some people have circuits which will, after a few minutes of ringing, you will be hung up on. That isn't us. That's automatic. Still haven't figured out how to deal with that unless we want to keep people on hold. Anyway, so 985-5735. Hello.
Hi, Roy. This is John up in the Antelope Valley, and I'd wonder if Bruce had had any still connections with another inventor who was along the same lines of him, Bob Cook Rodriguez, who had developed the CIP inertial propulsion engine.
I have met Bob Cook once.
I believe he said it was in Toronto. He's
That's
up
right.
in this area here and has had a similar machine, which is a handoff of centrifugal force in a percentage of an arc, which gives like a linear force in one particular direction. And I visited him just the other day, being an electronics technician in the same particular fields and similar interests and so forth. And like a lot like your project, his has become a project of approval by a lot of NASA mid-level people, but cut off on any particular possible funding, even as small as $50,000 for development in the top end of things. I just was curious if you happen to have any follow-up on that, but I was wondering if you have any new outlets for information for those of us home brewers who like to do it yourself and experiment with the device. If you have any other information on that, which might be available through another outlet besides your address that was just given.
Gee, I met Cook at the first international conference in Ottawa. And yes, I did see his machine. Yes, I do know it generates what they call unidirectional force. That's an action without a reaction. I also know that there are, when I was up there, someone told me that there was at least 3 or 4 other methods for doing the same thing, maybe with more or less efficiency. But the important thing is that this is supposed to be impossible. And it's another one of these terrible omissions in our world. Yes, he has really got something. I know that's possible because I've produced unidirectional forces with gyroscopes in my own experiment. So I know these things are true. I don't know what the hang-up is. There's a couple of comments I could make on that score. A friend of mine who's an electronics field engineer, instrumentation man at Vandenberg, said, I know one of those vice presidents at Northrop, and he said, I'm going to call him up and see why they don't want to put one of your end machines in the new space laboratory. And so he called up his vice president at Northrop, and he said, have you ever heard of the end machine? And the man said, not only have we heard of the end machine, but we've heard of Bruce DePalma. And he said, well, don't you think it would be a good idea to put one of these generators in the space platform or space laboratory? And the man said, but what would Hamilton Standard do about their fuel cells? And my friend said to me, well, he was totally nonplussed by this, but this is our basic problem, you see. And I could say the same thing about we had a program at the beginning about the shuttle and why it blew up. Well, the one company that I thought was going to be mentioned was Morton Thiokol. Now, Morton Thiokol is a company in Utah, and I don't know whether it's generally known, but the Mormon Church has a strong, what you might call space colony desire. The large families and these large communities all want to have their own little space colony or independent source of energy. So the space program would be of a great interest to the Mormon Church, and the Morton Thiokol people is a Mormon company, and also the former Thiokol executives are on the committee in NASA, which selected their very own company to do the work on the solid rocket boosters. So I'm saying, well, it may be all very interesting to keep all this work in Utah, but is that helping the success of the mission? You see, so I feel we've reached a point in. You convince the middle-level technical people. The same thing happens with me. I have people in the Air Force visit me. I have people working for aircraft companies visiting me. They're all very interested in the end machine, and they see it. And I said, when I worked for Polaroid or I worked for Westinghouse Air Brake, if I went to see somebody, I had to get approval. I have to get a trip report. I have to tell what I saw and all that. And these people come in and out. And they all say, well, we couldn't possibly mention this to our supervisors, but they're all intensely interested in it. And somehow this politicization, this has to end. We're going to wind up as a third world country over here. The other thought that crosses my mind now about politics is, everybody talks, this is not on your unidirectional force idea, but it's just a thought I might throw in, every month they talk about the balance of payments. And we beat on the Germans and the Japanese because they're selling us too many Mercedeses and video tape recorders, but nobody mentions the 60% of our energy which is imported, and all the money that's leaving this country. Nobody says what about the balance of payments to the Arabs? You see, we never even mention that, and we don't mention the huge expense of keeping a fleet over there to protect that. Now, what are we protecting? We've got to move forward in energy and propulsion in this society. I have memos from the White House that shows that they knew about the Cook propulsion system and ideas like that back in the early 70s, but they didn't do anything about it, so why not? You see, do we really want to be first in space or not? Right now, they have sessions where you can watch the Russian space satellite go over our heads every night, and you can sit out there and watch that. That doesn't make me feel any more comfortable in this country to see things like that happening. Even if my uncle was getting the contract, it wouldn't make me happy. But anyway, that's enough on this. So let's move on. I hope I've answered your question.
Yeah, I think it's pretty much covered it. And Ronald Reagan has told us that deficit is asset when it comes to trade balance, which is another Orwellian Reagan speak, sort of bridging that gap. But it's up to a lot of us progressive minds to set forth the fact towards mythology, because it's what's seducing us into consuming stuff that's like electrical energy that's artificially subsidized so we consume it at about 1/10 of its cost, probably somewhere in that area. But being in VCR repair, I see the definite effect on that, and it's going to be bad when the poor Japanese innovation in terms of repairability and serviceability makes its way into major product consumption in the U.S. I see a lot of problems designed around that, their element of disposable electronics. But I'm reminded, as a final thought, of one of the probably the most accurate lines I've heard about life in general, knowing that I've never met any person who could completely divorce themselves from greed entirely, unless it was someone with a little more passion for environment. Rolling Thunder strikes me as that sort of genuine passion. But I'm reminded of the classic line from Mel Brooks' Blazing Saddles, when it was the governor, Mel Brooks himself, sitting at the table saying, "Gentlemen, we have to protect our phony baloney jobs." And I think there was probably never a truer statement spoken about the reality of greed itself. And thanks again to Roy especially for mentioning at the Fox International Theater, I believe about a year or two ago, the Nikola Tesla movie that played there. Since then, I've really boned up a lot on Tesla's theories and found a lot of interesting information that Tesla discovered, that some of which I've been able to put to use and enhance my lifestyle using that. So,
all right. Do you have a dining room table that floats on air?
No, but you might be kind of amazed to see some of the resonance experiments I've done. At least when you see a few cracks in the foundation of an abandoned building that weren't there when you started.
Uh-oh. Okay, thanks for your call.
Yeah, thanks, Roy.
It's non-destructive testing.
Hello?
Yes. First of all, if you could give your address again, it went by kind of fast the first time.
Okay, you can write me at DePalma Energy, capital D-E, capital P-A-L-M-A, Energy, 1060 1060 Channel, C-H-A-N-N-E-L, Drive, Santa Barbara, California, 93108.
Okay, and my question would be, the situation you described with an engine that can put out more energy than you have to put into it, and you can hook up to itself to run itself. It sounds basically like a perpetual motion machine, and according to the laws of physics, this is not supposed to work because of the energy loss. Can you briefly explain how this is so?
Okay, the real thing is this. The idea of perpetual motion, as conceived by the physicists, is just as impossible as it's conceived, because you just cannot make something run without a source of energy. It just that's not a good idea. But the reason the end machine can produce more energy than it consumes is not because it's converting the input energy to the output energy or multiplying it in some way. It's exactly extracting the energy directly from space. That in a magnet where you're extracting the energy directly out of the magnet itself, from the rotating magnet, that is a principle operative here, different, qualitatively different from induction, where we do know that if we move a wire past a magnet, there is a drag due to the current flowing through the wire when we extract energy from the system. So there's a basically different principle of energy extraction operative in the rotating magnet. Now, there have been many theories put out about this, but basically, from the point of view of an experimentalist, you have these different effects, and when you have a different effect, you have a good reason to suspect that it will not have the same energetic conversion or generation efficiency as a different effect. Now, put into that the idea that there may be a difference between moving the magnet past the wire and moving the wire past the magnet, that the process might not be reciprocal. This might give a glimmer into the thought of making a generator that had less drag. You see, if we look at everything as being reciprocal, that is relative, then there is a lesser possibility of obtaining free energy if things are not reciprocal. Do you understand what I'm saying? Mm-hmm. And that non-reciprocality is why the end machine gives more energy out. That is one way of understanding it, you see. I don't want to... You see, it's very interesting. People send me these really thick layers of theoretical work. I have a couple of them in front of me right now about all the laws of electromagnetism and how to understand these things. And as an experimentalist, sometimes it really blows my mind, because I'm always trying to look at the world through a series of mathematical equations. I'm perfect. If I can test a simple physical effect and find that it does a useful thing for me, I am satisfied that right there. And the understanding of it afterwards, in terms of some kind of theoretical basis, is something that's going to be developed out of a lot of discussions between a lot of men and will come later. So I'm just suggesting to you that this sort of perpetual motion machine idea is not correct, because there is no way to make a machine to run forever without any energy into it. And that in the end machine, the extra energy is coming from a different mode of extraction of energy from what we call the free energy field of space, or the zero-point fluctuation field, or the various names that are given to that, the inertial field. And that's what's operative. So it's not a perpetual motion machine. And this This is just sort of like what they call a red herring that people throw up and sort of stops everybody for a while. But we have to, look, we're interested in the survival of our planet. We're interested in the survival of our society. We want to move beyond all these theoretical discussions and seize upon the effects and principles that are going to move the society ahead. And so that's where I'm basically coming from on this. And so if you'd like to come and see me and we can sit down and talk about some various theoretical ideas, I'd be happy to do so. But basically we have discovered a principle of energy extraction, and this is what it does. And that's what I can say about it right now. See, is that okay?
Yeah, I was just curious because it's a striking notion that if you did take this machine and run its output back into itself, what happens at that point? If it's generating so much energy, and if you can then use some of that energy to run itself, well, what sort of a state is it in at that point? I mean,
well, I would say it's in the same state as a solar cell is if the planet wouldn't rotate. In other words, if we lived on a world which had no night, and we had discovered an effect that if we held out in the space and let the radiation or what we ever call light fall on it, and we got electricity out of it, there you have a free energy machine. Now, the only reason you don't call it a free energy machine is because we have the idea that we're converting the light into the electricity. But if you give up on the idea of conversion, then the electricity is coming from someplace else, you see. That else being the free energy field of space.
Okay, thank you very much.
All right.
Good night. Hello.
Hi. Yeah, I have so many questions. First thing that comes to mind is how much energy and in what form is being generated by this machine? And is it AC or DC? And is how many amps or?
Right. It generates direct current, and the output of the machine is about 1.22 volts per 1,000 RPM, and we've run it up to about 6.5 volts so far, but we expect to be able to run it up to 12 volts sooner or later because we have to. With a piece as magnetic as what we have, it's very difficult to balance this piece because the magnet magnetizes the sensors that the people use for balancing, and it's something we're having to overcome. But it produces direct current, and the current output is set by the conductors that you use in the machine. Our machine has been designed for 10,000 amps continuous, so that if we took 10,000 amperes out of it at 12 volts, that's 120,000 watts.
See, that's so unlike any conventional thing that would produce at a low voltage like that would produce nothing like that massive amperage.
Well, that's right.
Does the permanent magnet become demagnetized as the machine runs?
No. What we've done is we've built a self-exciting feature into this machine so that as you take more current out of it, the magnets get stronger. So
my gosh.
Yeah. And this was something suggested by Tesla. I would say this. If you want to see all the details of this, it's all in our report. And write a note to me and I'll send you a copy.
Couldn't you just hook a 6-volt DC motor up to drive it? And I mean, it seems like getting the running it off itself is easy once the machine's made.
It is. Well, the fact of the matter is this. The exact details are that there are other losses in rotating machines that come from wind losses, bearing losses. The motor efficiency of a DC machine is not constant. It varies over the speed range. And basically, the reason that most people haven't been able to make self-running machines yet is that they've made the end machine part of it, but then they haven't perfected the Faraday disc. You see, a Faraday disc motor, which is just a copper disc in a magnetic field, and the current is fed in at the edges and taken out at the axle, and the disc goes around. This motor has been made at efficiencies up to about 96%. And if you look at all the losses in the system, if you have an end machine with a 3 or 4 to 1 gain and a Faraday disc with about 96% efficiency, plus all the mechanical losses to bearing and wind and other things, you can get a self-sustaining machine, but you have to bring the speed of the combination up to about 6,000 or 7,000 RPM. And in the case of we have it all plotted out, and we have in the report here. But the reason you don't want to use a conventional DC motor is that the efficiency isn't quite high enough. Furthermore, conventional DC motors operate at higher voltages than N machines put out. Like my machine might put out 12 volts, okay?
Well, wouldn't that amperage would burn up a conventional machine anyway?
Well, yeah, true enough, but a normal DC motor might run at 50 or 100 volts. And okay, suppose you could get a normal DC motor that might have 85 or 90% efficiency. To convert the 12 volts output of the N machine up to the 80 or 90 volts for the DC motor, you'd have to use an inverter. And at the power levels required, the inverter efficiencies are around 80%. So the best thing to do is to use a Faraday disc motor which can operate at the voltages that the N machine generates directly. And that's the route that everyone else in the world is following, including myself at this moment.
The Faraday disc sounds like the Ark of the Covenant.
Well, it's I don't know whether it's the Ark of the Covenant, but it's
the disc part of it sounds like
magical.
that kind of a does it generate static electricity? I mean...
Well, the Faraday disc is an invention of Faraday when he discovered that if you took a copper disc and you turned it or rotated it in front of the pole of a magnet, it would generate a voltage between the edge of the disc and the center of the disc.
Oh, yes.
And conversely, if you held the disc in front of the pole of a magnet and you put voltage on it, the disc would rotate. And this motor is the most efficient, lightweight, most powerful DC motor possible. And the only reason it hasn't been used is because the voltages are low. But it works perfectly with an N machine. That's why. But you see, look, all of these things, all these things take time to machine, to design, to construct, and to build. They're not articles of commerce. And that's why many people who thought this was a lot easier to do have had a little hard luck. I mean, because it costs a lot of money, and the principle is simple, but the precision has to be high. That's all.
This is remarkable. I just wish you all the best and hope that you succeed. I'd buy one if I could afford it.
Well, I
tell you. What'd you sell one for?
When I'm talking over the airwaves tonight, I hope I'm speaking to all those liberals out there that want to see a better America. And, if you think about...
Better America, a better world.
A better world. All of the things that we think about in our society which are wrong with it, and somehow you can trace back to energy. I think you could even trace energy back to be the source behind the reason people are sleeping here in the streets in Los Angeles, you see. So you think about all the problems in the world and all the talk and all the politics which goes to treat the ills of our planet like the allopathic doctor hands out medicines to treat the symptoms of some patient. The real cause of our problem on this planet is the high cost of energy. The real cause of our balance of payments problem is the fact that we're importing our most basic resource. And I don't know why this cycle can't be broken, but it's going to be the liberals of this city or of this country have to support something as far out. I mean, if you read in all the science fiction...
It'll break us.
That's right. This is the one solution that's never been brought up in any major way that could possibly change the whole world. And you see, the money that got me as far as I got right sitting here in this chair was liberal money from a wealthy liberal, you see. And if it isn't those liberals that are going to, if they're going to sit there and wait for somebody else to do it, we're all going to be swallowed up by laws like this electric company.
Hello?
Well, I really have no questions. Just a couple of comments. Number one, we all know the political ramifications of all these free energy machines. They're beautiful. And if you look at it from the government standpoint, if we produced all the hundreds of energy-efficient machines, what would happen to our basic economy? It would almost collapse. We have to work towards a progressive and cooperative way, I think.
Why would you say it would collapse?
Well, all our tooling and, the major industry, it's all running on energy that's basically set up on a sort of a choreographed type of basis,
It's a choreographed to death.
Yeah, well, I think I agree
Dance
with you.
Of death.
It's a downhill situation here, but what would happen if we instantly made it all free? What would happen to all the, for instance, jobs? And
I hope we'd have a lot more jobs, because without paying for the cost of imported oil and imported energy, everything in our world would be cheaper. Besides that, we wouldn't have a lot of smoke smelling up the air and cutting off the sunlight, which is preventing us from growing food. I mean, the whole thing connects together. The thing is, if everybody in this country was going to get a new car, that would put people back to work. If everybody was going to get a new boat or a new airplane or have a unit in their home or could have a trailer they could take out in the desert and live, there's such a tremendous industry waiting here to happen. And that doesn't say anything about the fact that free energy will allow a private company to go into space. You know, suppose you want to go into space.
I fully agree with what you say. I'm just going a little bit deeper into it. Some people would have problems and other people would benefit. And I think we have to allow ourselves to understand the progression into it instead of flat-out complaints.
Well, no one's complaining here, and as far as the progression into it, the rest of the world is moving ahead on this on a much higher level than is happening in this country. So,
yeah, well, we take it for granted our quality and leisurely lifestyle, and I think it's making us lazy. Yeah, I'm an inventor myself, and I don't really want to get into any debates. That's low class at the moment. I would like to ask one other thing. Are you serious about if someone would want to come in and speak with you face to face?
Sure, I do it every day.
Okay, I mean, because I can rattle off my rendition of all these energy-saving devices.
Fine.
I don't want to
do
do this on the phone. It's not the time to do that.
Fine.
If you're serious.
Of course I'm serious.
What is convenient?
Convenient is business hours. That's 5 days a week from 8 in the morning till about 5 or 6 in the afternoon, and that's all I can handle. And on weekends,
I'm going to set up an appointment on the air with you.
That's fine.
Are you in the book?
Sure. Santa Barbara.
Okay. If I was to call you sometime tomorrow in the afternoon.
I'll be asleep. Leave a message on my machine because it's going to take me about 3 days to recover from this.
Really? Yeah, I brainstorm a lot in the middle of the night myself. That's what. See, me and my friends, we don't like to party out all hours of the night. We like to sit back and we brainstorm, and it's incredible, you know, all the stuff that comes out of it. And our financial status is, you know, we're almost so broke we can't even pay attention.
Well, let me tell you one thing.
I'd like to speak with you face to face, if that's possible.
Fine. But if your believe it, if your brainstorming is really going to take you somewhere, you will be able to make a living out of it, and you will succeed.
I'm going to be successful. That's all there is to it. I'm pushing myself towards it.
I mean,
I've had many failures and many successes, but
well, all right.
Out of 100 ideas, there might be 3 that really have the substance, and I allow myself to face that fact.
Well, and then once you have the idea, you have to also face the fact that before you can realize the idea, you may. When Edison said it's 99% perspiration and 1% inspiration, he was right.
Oh, yeah.
All right.
Well, I do have the ability to conceive, design, and engineer.
Well, then we ought to have a talk.
I will come and give you a call, and I'd like to just go face-to-face, not on the phone.
Fine. All right.
One other thing, I'd like to comment on that centrifugal energy device. I think it was the second caller mentioned.
The unidirectional force, yes.
Leonardo da Vinci drew some sketches attempting to disprove the perpetual motion theories. In case you're interested, if you want to go into
I don't know. I've read his note.
History on that.
I never saw one of them. All right. Well, let's have a chat sometime.
Will do. Thanks for your time.
All right.
Bye-bye.
Bye. Hello, you're on the air with Bruce DePalma.
Okay. I'm an electrical contractor, and I've always been interested in the energy creating devices. Tell me this. I heard Mr. DePalma mention earlier about Mr. Joseph Newman, and I saw briefly him on a show, and it gave a brief picture as to what his machine looked like, and it looked like a humongous abstract invention there. And I've heard the announcer mention that your machine is about the size of a copier. Now, is this the final product that you someday hope to market in this size, or
its present size is about the size of a Xerox machine, one of the floor models, and it's that size because that's the largest thing we could build with ordinarily available shop equipment.
So to put this into a practical use perhaps someday, the units would be, what do you give in terms of 2, 3 times, 4 times larger for home use to create the amount of power that would be necessary?
Oh, no. This machine that's already existing could create enough power for 3 or 4 homes. It's quite powerful.
Well, in in essence, wattage-wise, powerful, but voltage-wise, the home would have to go through some kind of changes.
Well, right. Generally, people like to use higher voltages than 12 volts, but the thing is, 12 volts is all that you use in a car,
Right.
and campers use 12 volts. So all televisions and hi-fis that work in campers and cars would work on 12 volts. So it's not so far away.
Right. So, but basically, the homes as existing now have to go through the changes to convert into a 12-volt system. Then.
Well, that's right. That's right.
But in essence, the machine you have now would be able to furnish that home with enough power to cool and refrigerate food.
Yes, exactly. It's just the same kind of electricity as the power company is giving you. And also, the 12 volts can be converted to 110 volts AC.
Right. Through other devices,
through electronic switches.
Right,
Yes.
right. But in essence, if one wanted to utilize the most effective cost-saving features in order to use your machine right away, he'd have to have his home set up to use 12-volt DC.
Well, not right away. Right away, he could build a converter and convert the 12 volts.
But that's what I mean. That would be an extra device, though.
Yeah. But the thing is, those devices are available, for $300, and people use them in trailers to run television sets from 12-volt batteries. I mean, they're articles of commerce.
Say, in using your machine to power another generator to create some, say, typical 120, 240-volt AC.
Yes.
That could be of usage, incorporating that system.
Oh, sure. You see, once you have direct current and it's above a certain voltage, you can easily convert it to all other voltages and currents and frequencies.
Now, in terms of what I've heard your machine does versus something like Joe Newman's, is this basically based on the same principle? It doesn't sound the same.
Well,
But his was based on something that kind of through the current theory in terms of deriving energy from magnetism. It kind of really kind of threw that in the dark ages, the present theory.
Well, look at it this point of view.
Go ahead.
AC, I'm not a theoretician. If you want to try to understand Joe Newman, you read his book and you have to plow through 100 or 200 pages of his theoretical ideas about the way magnets move, and that's how he presents his ideas. I'm not trying to do anything like that. I'm saying that I'm working with the basic experiment that was discovered in 1831, and I've just built and enlarged it. And so I'm not trying to put a theory out. I'm saying it's sort of like, here it is, and you read the meters, and this is what it does. And if you have a theory, well, you put it down with all the other ones that come along. You see, whereas Joe Newman's difficulties stem because he's basically trying to patent his theory along with his machine, and that's a lot of people are having difficulty with that.
Well, at this moment, due to your funding problems, and of course we all have those, if you were to generate enough cells currently of your model that exists at this time, is that not a ethical or logical pursuit for you at this time, or are you just waiting for the great big piece of funding that perhaps would get you to set up a more efficient or more productive manufacturing?
Well, gee, I hope it isn't too late at night to think about something like this. I think the situation of the free energy and its introduction into society on this planet is a mythological event. And along with mythological events go all the things that happen to mythological characters. And I've often thought about the shipwreck of Odysseus, and here's a man who had a great estate and a great warrior, and he's washed up on shore and he's lost everything, and he's every avenue seems closed to him, and then the goddess appears in some form, and someone walks out from some shrubbery and says, "Come this way," and fine clothes are waiting. So what I'm basically saying is that since so many things I have a situation where, as I said, the company that was going to buy my machines was out of business as of last Friday, and my backer is sort of very ill and can't be reached anymore, and the people that originally wanted my generator just because it produced more than it consumed now want a self-running machine. This is a situation which at the same time has so many possibilities and is so impossible that only something mythological could take place. So I'm not saying that I'm not looking for my big break or Santa Claus or something, but I do think that it's about time this country got behind this idea. And that's the thing I would hope to happen. It's not anything personal with me. I mean, people have told me many times, Mr. DePalma, you are going to be a very famous man, but where will you get the money? And I said, and I've always said, this is California, I said, somebody's going to give it to me. So that's how I look at this whole situation.
Well, I'm looking at it in terms of a right-of-way situation. If your machine was marketed right now, what would you figure would be the estimated cost of purchasing it?
One of my machines costs $150,000.
As of right now?
As of right now. And this will give you a generator which can put out up to about 12 volts at 10,000 amps. And it's the basis from which you can construct a self-running engine, if you have enough wherewithal to get the facilities to do that. You see, basically, what we have made takes a great deal of skill and expertise in its construction. This is the gluing together of all these magnets and the balancing of this thing and all the materials that go into its construction. So my role in this thing is not a theoretical one. I'm in a very practical role of constructing something from the ground up, from the very metals and glues and materials. And I'm saying that here is a very useful generator, and Dr. So-and-so in laboratory of the Hughes Aircraft Corporation that has billions of dollars of money, you might want to buy one of these things because you could, I'm sure, figure out many useful applications for this machine. Not only can it develop this 100,000 watts continuously on a pulsed basis, I have no idea how much power it could put out. It might put out megawatts as far as I know. We have no way of testing it at this time. But basically the design of the rotor part has been really gone over, and I'm very happy with it, and I wouldn't change any of it. So that it says that you're ready to start making this available to others. When the laser first was invented, I worked at an R&D company, and everybody was talking lasers, and finally we found some little outfit that for $1,000 sold us this little squeaky laser that if you tweaked it just in the right way and knocked on it and got the mirrors just so, you would get a dim red beam that came out of this thing, and that was a laser. But the fact of the matter is that was the basis of a whole lot of electrotechnical developments which changed our lives, and so it has to start somewhere. And so we think we know enough specialized knowledge to make the most important part, and that's what we're selling right now.
Okay, I see what you're saying, but what is it going to take to make this available for the average homeowner or person that wants to utilize this right away? Is it going to take a manufacturing scheme for you to do this at a lower cost? I mean, not just $150,000 in Southern California will barely buy you a home. Now, how much, in time, I'm sure you would like to sell your machine cheaper, but could it perhaps in time be made cheap enough?
Oh, I think so. The basic problem is it would be a very inexpensive thing to make if it weren't for the difficulty of working on it while it was magnetized. That is a humongous problem to deal with, especially since it's so intensely magnetic. That's what makes it really tough. And we've thought the problem of magnetizing large magnets made out of this neodymium iron boron, which is a very, very difficult substance to magnetize, is so difficult to magnetize that, as I said, you can't make a piece more than about 3 inches in diameter and 1 inch thick. And we have hexagons 2 inches across. Now, we've thought a lot about the magnetizer that would be necessary to magnetize the whole rotor all at once. And that's another R&D effort that's worth a couple of $1 million. But when you have a thing which many people have made around the world and verified, and which whole governments on the other side of the world are pursuing, I have written reports on these things. Don't you think it's about time that this country did something? The guy that first discovered that neutrons from a radium beryllium source, which you could put together out of radium needles and beryllium foil back in 1938, if you took this radiation and impinged it upon a uranium foil, you would get huge bursts of energy. The guy that discovered that radioactive phenomena, which was demonstrable to lectures, and people went back to their laboratories and did it, they didn't have to build the first nuclear reactor. I don't feel that I should have to build the first Niagara Falls power plant single-handedly. And I think this ego trip of sticking with the old technology and the old ways is killing this country. And here you have a first-rate scientific breakthrough like this, and I'm not talking about it anymore as if it were something that was pie in the sky. This is right here, right now. And why we sit still and fool around with atomic power plants and oil pipeline, I can't understand it. But if this material is published in India, in the Eastern Asian Engineer, the next people that are going to pick it up are the Chinese. And the thing is, where is it going to leave us, you see? So, I guess I've said all I can say on this stuff, but I want America to be a great country. It was a great country in its ability to turn out technical things. And I've been through the era of greatness in this country. I think the standard of living we have should make us the best, most intelligent problem solvers and doers in the world. And to let other people take this away from us is just sinful.
Well, one other avenue of pursuits for financial backing, it might be telling you something, is that perhaps you need to venture out on an international scale. I don't know if you've done that. But
of course I have. I have a joint patent in India on this machine.
And no results?
Lots of results. The Indian Government Atomic Energy Commission is doing this in a large scale.
I mean, in terms of supporting you here in this little niche called Santa Barbara.
Well, let's put it this way.
Down to that level yet?
I don't know. We'll have to see.
Okay,
But tomorrow morning, something may drop on my doorstep. I don't know.
Okay. Well, it was nice talking to you, Mr. DePalma. I'll be sure and write you for some more information.
Nice to talk to you.
Bye-bye.
Good night. Hello?
Oh, gee, I'm surprised to get on. My name is Don, and I'm a technocrat. I don't know if you've ever heard of Technocracy Incorporated.
Well, I've heard of it, but what is this leading us to?
Well,
you're going to be made a saint.
No, I was listening with great interest to your talk, and I have a background in a lot of mechanical things. I ended up being a tool and die maker. So I was quite fascinated with what I would have said was impossible. Okay, so I accept your word and let it go at that. Well, when you came on and said, I'm worried about the country, that's right up my alley. Technocracy has been trying to tell the people of this continent that our price system, our present socioeconomic system, is no longer able to function. And that's the reason why we have the tremendous debts. It's very simple. The advent of James Watt and his development of the steam engine brought about a change in the way people live. And that change is accelerating, and it's got to the point now where the people, the production is done by machines at, I don't know, 7 cents a kilowatt or something like that. And it takes about 20 man-hours, or a little better, to equal 1 kilowatt. And so the people cannot buy back what is produced. And that's why our country is in so desperate straits now. And we're trying to talk the people into examining, thinking about our technological social design, which is a scientific blueprint for the operation of the North American continent, leading to conservation of energy, conservation of resources, conservation of people. Because it's not only what's happening in our country now is not only destroying our productive capacity and destroying our educational system and destroying our the ego of our people, causing them to take in a lot of drugs and other things. So I'm speaking to you from the standpoint of giving you hope in a change in our social system, our socioeconomic system, could very easily lead right up your alley, and you could be a second James Watt, or the people that are involved in this thing.
Well, all right.
James Watt, the ex-secretary.
There's no reason for existence if happiness and fulfillment aren't here for us. So why? I don't know, but how I'm doing it is to put this machine out into the world and hope that the abundance that this brings will have as its consequence all the other kind of abundances that you would like to see happen from your technocracy. Okay?
Well, all I'm trying to do is get some way of disseminating the information that we have not been able to disseminate adequately for the past 50 years. And somebody like you that has developed an earth-shaking, made a development there that is earth-shaking, it seems to me would have an interest in what's going to happen when this finally comes about. In the first place, I see that it seems to me that all the powers that be involved in our financial structure are against you, because you're going to be bring about cheap energy, and that's in the power structure, the hydro development and the atomic development and even the sunshine development that Governor Jerry Brown helped start.
Well, you see, I understand these kinds of things, but you have to look at it another way. You know, these kinds of institutionalized monies, like the DuPont monies and the Rockefeller monies, and the old oil monies and the old land monies and stuff. How about a few new billionaires on this planet that might come out of spaceship construction or new kinds of electric cars? I think it's about time that we had some creative new young millionaires. You know, back in the 30s, you could turn on the radio or you could look at a newspaper and you could see Edison and Firestone and Ford, these great industrialists. There they were right in front of you, and they're making the whole country go around. Who do we look around in our country now that's the great scientist or great inventor who has some great laboratory doing great things? Nobody. No one. All of our technological talent is sucked off into some laboratory to produce high-tech inventions which are classified even before they're thought up, and nobody ever sees them. It's a perfect breeding ground for incompetence, because
exactly true.
All the mistakes are covered up. And the thing is, I don't expect to be able to press any magic button and loosen this up overnight, but every time I get on the air, I certainly put it out that as a country we're losing it.
That's right.
And we have so much talent here. We have so many young minds that could be doing so many more constructive things. You know, somebody said the other day to some audience, how many people in here have videotape recorders? And people raised their hands. And he said, do you know there isn't one of these things made in the United States? Not one? And the thing is, we can't keep sending our oil money out and our video money out and all this stuff. And besides, I'd be proud to have an American portable videotape recorder. For Pete's sake, maybe we could think up something that would be a little less complicated than the Japanese ones or something. You see?
See, you know, that's the reason that, excuse me, I didn't.
Well, I get very angry over this whole thing.
Well, I am too.
Because there are people.
I've been working at it ever since 1942.
Well, you see, what we have in this world is we have a national government in this country that only worries about the government, of the United States, and we have multinational corporations to whom the United States is only one little, one of their clients or something.
I understand that.
And the thing is, that means that money flows all over this world, and it doesn't make any difference whether it winds up in Hong Kong or Singapore or someplace else. And the thing is, what's happened to our feeling for ourselves? I mean, even if I was the president of a multinational corporation, would I want to take all the money out of my native country and put it in Hong Kong or something
now?
Well, I don't feel that way.
Well, all right, and the technocracy says we can get along very nicely without money.
Well, I don't know about
energy
that.
On the basis of distributing the wealth and the the production of this country and bring about a different way of living, a different culture.
Well, I think lower energy costs will do that, but what's going to happen after that, I don't know. But I do know there'll be a lot of young energy released, and I hope that they can think up something better than their fathers have come up with, is all I can say.
Talking about. It's perfectly possible to bring about a major change in the culture of this country and improve in every fashion that you can think of. Get rid of crime, improve our educational system, improve our medical delivery system, and get rid of dope and all that kind of stuff almost overnight.
You could do all that overnight if you substituted for all those things a future for this country.
That's right.
A future that young people could aspire to.
That's what I'm talking about.
I know young people that want to go into space. They want to go into space so badly that's all they think about, morning, noon, and night. And the thing is, what do they have to do? Well, they have to join the Air Force, or they have to join the Army, and then they have to go through that kind of a, what should we say, detoxification
right.
before they can get on the space shuttle, maybe. And the thing is, what would happen if space exploration were a private enterprise thing based on a new source of energy, and maybe even a new source of anti-gravity, which could come out of all of this? We can't sit here and let other people do this, or we're going to wind up as a third world country.
That's exactly what we're...
Well, that's what we're on the way to.
If these kinds of developments aren't encouraged. And I don't see that encouragement coming from our price system operation. And if we can turn over into a technate.
Well, you want to turn it over from one system into another. The young people that hear me come and see me, and we have quite a little physics community going. And, you know, if you talk about universities, I don't think the university operative in Southern California is UCLA. It's the university operating here is KPFK. And you can tune into a lecture every hour on the hour, morning, noon, and night here. And they're good lectures, too, you see,
right.
For free.
I'm aware of them.
Okay. And so people who want to change will go and find the things that they think they need to have to stimulate their minds to get them the lives that they want to live. And that's what we depend upon. I don't depend on some system to come in over some other system. I expect people to act and go for the things that they think are going to make them live as fulfilled human beings. And that does not consist of supporting the old dinosaurs and the old ideologies and isms. And so I think there have been a lot of progressive philosophies which have been evolved, but I really feel the future of the world has to go beyond philosophies and ideologies, because generally what these things do is just different ways for people to impose their ideas on each other. And that even comes down to the law of physics, you know, the laws of physics, which everybody has to accept. So it's a kind of autocracy I don't support. I'm for freedom. And I don't know what this is going to take this world to, but I certainly think it's going to be better than what we have now. And we certainly know where we're going if we stay on the path we're on now, you see, with the smoke closing in every year. But this is not a subject I want to get onto, so we should switch.
Thank you, Mike.
Good night. This is KPFK Los Angeles. You're listening to Something's Happening, Dynamite Radio for night people, Monday through Thursday, midnight to 6 a.m. Tonight, January 29th, 1988, our live guest is Bruce DePalma, the inventor of the N machine. And this is, what, your fourth, fifth,
sixth,
seventh visit with us?
Quite a few.
Hello.
Hi. Wonderful show. One of my favorite guests is on. First time I've been able to speak to you on the phone. First of all, if you would repeat your address, I'd appreciate it.
My address is DePalma Energy, capital D-E, capital P-A-L-M-A, Energy.
Yes.
1060-1060 Channel Drive, Santa Barbara, California, 93108.
Okay. And what do I need to send in order to get this report on your machine?
Just send me a lecture. Send me a note that you want it,
okay,
with
great.
your address on it.
Okay. First of all, I was going to mention a couple of books because I'm curious if you have seen them. One of them is called How to Build a Flying Saucer.
Yes, I've seen that one.
And the other one is called On the Far Frontiers, or the Frontiers of Science by G. Harry Stein, which came out a couple of years ago.
I haven't seen that one, but I know G. Harry Stein because he used to write articles for Astounding Science Fiction.
Right.
Yes.
That's a very interesting book, the Stein one, because And I think that anybody who's listening who's interested in experimenting on their own with various things should look for it. Even if it's out of print, try to find a used copy somewhere, because he basically has plans on how to make an experiment with various devices such as a Hieronymus machine, pyramids, and various other things. And it's interesting because he, in his introduction, says he was a skeptic initially when these various things were presented to him, and because he's worked, I believe, as a rocket scientist and various other things, and he decided to try them out. And lo and behold, he tried some of these things out, and when they worked, he was absolutely astonished, but decided to investigate it further in an empirical manner.
You know, you've hit on a really important point, because as an experimental scientist, you don't, and I'm talking about you and me both,
right.
When we do experiments, we really don't understand how much our prejudices prevent us from doing certain things. And when we do an experiment, we do it generally to find just exactly one specific thing, and if we don't find it, well, it didn't work. But something totally different might have happened that we didn't find because we weren't going to look for it. And it's when I think about the experiment I did with dropping a spinning object. Now, why didn't anybody ever try to drop something that was spinning as opposed to not spinning it? And it was that simple, that basic, but nobody ever did it. And I think that your prejudices, because people would look at you and say, well, why would you ever think that such a thing would happen if you dropped a spinning object? And then you'd have to spend 3 or 4 hours trying to convince them of something that you have hardly understood yourself. So basically, you got to go out there and try it. And so I'm all for doing that. And you've got to try it with your eyes open and try to be as unprejudiced.
Right.
But
well, I'm an empiricist, and one of the things you referred to before is UCLA is not the university. I certainly agree with that, because I went to UCLA, and in my first year, I was a science major, and I've been interested in science and technology all my life as a, I guess, interested layperson. And here you go, they swamp you with all these 3/4 of calculus and this, that, and the other thing, and it's impossible, absolutely impossible, because the quality of the teaching is absolutely the worst. There are these people who stand up and go through the motions, and they teach to the students as if you're already expected to understand it. Therefore, it's impossible to be able to understand it the way they teach it. They expect you to already be at the same level of understanding they are.
Yes, it's a classical case of non-empathy.
And then in the physics area, I don't understand why you can't teach physics without this reliance on everybody having to be an expert in higher mathematics.
Well, the question you ought to ask that professor the next time you see him is there any proof that he can bring out that says that mathematics has any relationship to the results of physical experiments?
No. Well, that was a long time ago, but I fled into the humanities, but I still retain my interest in science and technology. And a perfect example of what you were saying about preconceptions is I was reading an article in a computer magazine about the new 9600 baud modems, and one of the funny things is it said that a few years ago, when the first modems were coming out, all these computer engineers were saying, we'll never be able to make a faster modem than a 300 baud modem using the current telephone lines. And here we are, and they're already having, ones that are 12 times as fast.
Well, back in the 30s, what they couldn't smash was the atom. Mm-hmm. They did that one when they blew the bomb up. Then the next thing they couldn't pass was the speed of sound, and so they cracked that one. And, now it's the speed of light, and, of course, anti-gravity, impossible, and all of these so-called barriers are later found to be imaginary, and that's why our culture does make progress from time to time.
It was once said that it was impossible for people to go faster than 25 miles an hour because our rib cages would crush if we went faster than 25 mph.
On the Faraday disc, I'm surprised. It is very efficient both as a generator and as a motor.
Yes, it's the most efficient in terms of our present understanding machine.
I'm surprised, or I guess maybe I'm not surprised, but it's disappointing that given its efficiency as a motor, it's not employed as a motor in a lot of the consumer electronics we use every day because they eat power. I have I have all sorts of consumer electronics. I'm standing here now surrounded, VCR, laser video disc player, etc. Not one of, by the way, piece of it is made in the United States, sadly to say, including my portable computer. And, for instance, the little portable Walkman I have, cassette player, takes 2 batteries, and, after you put a cassette in it for an hour, those batteries are completely exhausted.
No, I know. Well, you see, the Faraday disc was never taught to me in school, and I'm sure all the engineers that have been graduated since I got graduated never even heard of it. So I just think it's just not taught, and it's not investigated.
Well, unfortunately, I think there's also a tremendous amount of inertia, which is very infuriating. Inertia with bureaucratic institutions, and also, unfortunately, a lot of rank incompetence with people who call themselves scientists. And the perfect example is the space shuttle. I'm very sad because you were saying earlier, people who want to go into space. I'm physically handicapped, and space would be a wonderful environment. I'd love to go into space if it were, relatively safe. And here we have this problem with the space shuttle, which is rank, in terms of the engineering of the booster and everything that went wrong, it's rank incompetence. And what really shocks...
It's not incompetence on the part of the engineers, it's the incompetence on the part of the management, because the engineers on that day did not... the guys took a chance with getting fired.
That's true, but since then, what infuriates me is here was the problem, these O-rings were burning through. And after that would happen, you would think that the simplest answer would be, let's use a booster that doesn't have O-rings, that's solid, that's not segmented.
Yeah, but then that wouldn't have been made by Morton Thiokol.
Exactly. There was a company in California.
I know.
Okay, I don't want to go into too much.
No, but it's the truth. Yes, you're right.
What bothers me is I have a sense of absolute moral outrage over this. Whenever I hear, one of the attitudes that infuriates me is a lot of people have this attitude of, well, we always knew we were going to lose one, we always knew there were going to be a certain amount of accidents, blah, 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 when this was a totally avoidable accident. This wasn't something that was completely unexpected. There were even hints that there had been, minor failures before.
When I was in teaching during the days of the Vietnam War, and I would come home and visit my family during vacations, and I mentioned to my stepfather one time that 55,000 American boys got killed in Vietnam. He looked at me and said, "But Bruce," he said, "that many people get killed on the highways every year."
Oh God, yes, I remember somebody who used to keep saying that over and over, and I just can't understand that kind of thinking. But it gives me a moral sense of outrage, that and many other things, when things like that are going on. And now they're having the same problems and more problems and more problems, instead of just saying, well, the hell with it, let's go to something that works, instead of keep trying to repair something that is inherently not working well. And that's that's what I call a rank incompetence, whether it be in management or if it is in engineering.
Well, it depends on... I know what you're saying. I basically feel that many engineers, or most engineers, try to do the best jobs they can. What we're looking at in our country is a situation where, like some octopus, the industrial companies that are behind the military industrial complex and the defense business have completely sucked all the technical talent into their web and taken it away from consumer things to produce things which are never used under conditions where nobody ever knows whatever goes wrong, and there's no evaluation because of the secrecy. And the thing is,
very expensive.
It's not only that, it's not only very expensive, but it's not very effective. And the thing is, all I can say to you on the score, I would rather think of less of trying to change people's minds about that than trying to bring people together who want to go into space and who want to work on free energy and who want to make these new ideas come to fruition. Because
I agree.
This project, this free energy idea, has brought together the most creative and talented, artistic and heart-filled people that I've ever come across in my whole life. And for the same reason that I'm doing it, they give themselves to it totally, because they're in love with life and they want to see life on this planet go on. And I think that rather than railing at systems and bureaucrats, I think that the young inventors and people should gather together and do this stuff and make it happen. You see?
Let me just hit you with two quick last questions. One, have you ever considered having a computer bulletin board that would be a source of the information, such as the report and other documents, that people could contribute to or download from.
Many of my intelligent young friends have suggested that, but then I also point out to them that that computer goes on my overhead, and I don't want to have any overhead right now. So if somebody wants to do that for me, see, this report, which is, I will send you if you want to write me, this is already being published in Europe, and it's being published over here in this country, just right out of my hands. So it's in circulation. And generally, the people who do things like transmitting and publishing have their own computers and do that service as a part of the new age networking, which has been going on for quite a while. But the same people have been doing this, and they're generating a change through it. You see.
My second question was, I'm a freelance writer, and I was interested if you would be not averse to having this written about, and I hope published in some magazine.
Oh, it's been written about by many people and published in many magazines, but if anything more you can contribute, it'd certainly be fine.
Well, I would be interested in writing perhaps an entire book on the subject of this and other alternative energy.
Wonderful. Well, then you and I should have a person-to-person chat if you can.
Well, I'm going to first write for the report, and I'll also contact you and that. And I happen to have a spare computer around that may just have, at least initially, some capacity to be at least the beginning of some kind of a network if people would want to access it.
Well, maybe you could ask KPFK if they could use a thing like that.
Well, I'm afraid they need IBM compatible. It has to be rather oddball, discontinued. Japanese and other Japanese, I have only portable computers because I find I like laptop computers, because I can sit in my easy chair and not have to be sitting in front of a desk all day long, because with my severe arthritis that I've had for years, that's impossible for me. And this one I have two of them, both are Japanese. This one is a sort of strange one, unfortunately. All my stuff is 8-bit technology. One of them is CPM, so that's somewhat compatible, but that's the one I use all the time for my writing and such. But this one I got for free. I really don't use it very much, so it has a built-in modem and maybe could even be used.
Well, look, why don't we get together at some point, and we'll continue this conversation.
Great.
All right, then.
Talking with you very much. Bye-bye.
Good night, then.
Good night. Hello, this is KPFK. You're on the air with Bruce DePalma.
Hi, I'm calling about your dropping spinning object. Could you describe that experiment in enough detail that I could possibly duplicate it? Because if what you say is true, the implications are mind-boggling.
Well, yeah, of course it is true, and the implications are mind-boggling. There's two ways to do it. The rigorous way, well, both ways are rigorous. One way is to take a 1-inch diameter. The way that was done, there was a man in the University of Pennsylvania, a man named Arnold Denenstein, and he did an experiment which took a year for him to set up, where he had a glass tube which he evacuated. He used 1-inch diameter steel ball bearings, and he magnetically suspended them from nails with a little electromagnet, and then you can put coils around one of time it's full with timing lights like they use to time cars or something like that. And you'll find that it drops faster. So you can do it either by dropping the whole gyroscope in a box, or you can drop the spinning ball bearing in a vacuum.
Yeah, it's an amazing idea that it's amazing nobody's stumbled across it before. One other question. I'm new to the theory of this. I've only heard you a couple of times. From what you said, and I plan to write for your report, but what you said tonight, it sounds like rather than getting energy from the fabric of space or free energy, you're simply converting magnetism into electricity, and that part of the cost of that, part of the energy input that goes into your magnetic motor would have to be included in the energy needed to create the magnet in the first place. In other words,
suppose
it's a lot of trouble to make these magnets. Does it take a lot of energy or electricity to make them?
Oh yeah, they take a big jolt, but once made, they stay that way.
Well, but you said that your machine will continually magnetize the magnets.
Yes. That not only it can't magnetize them, but it can reduce the state of demagnetization of them by virtue of the fact if you take a magnet and you just put it in the air without anything around it, like what they call a keeper. It will there's a strong demagnetizing effect on the magnet just because it doesn't have a keeper on it.
Right.
Now, that demagnetizing effect is counteracted by the self-energizing feature that we have built into the machine.
Well, so Is that what you're doing, though, converting magnetism into electricity, or are you tapping on something independent of the magnet and of your motor?
Well, you see, that's the whole point I've been trying to sort of lay out all night. I am not a theoretician who's trying to say I'm doing it from the magnetism, or I'm doing it from space, or I'm doing it from this and that. I have found an effect which has certain properties. It has been explained as extraction of electricity from space, or you can say that it's coming from the magnetism, but I don't know who's going to have the final word on this. I'm more interested in its practical application.
Yeah, I'm not knocking it.
No, it has nothing to do with it.
If you found a way of creating an electric field that generates more energy than it puts into it, it's an amazing idea. I'm personally more interested in the nature of reality, and this seems to expand and overthrow some of my pet theories.
Well, I hope that
it's very exciting.
Well, I hope that you think about the idea of non-relativity, which is an interesting idea, that moving A past B may not be the same thing as moving B past A if A and B are not the same thing.
Yeah, I'm thinking about it, and I'm aware that there are some other flaws in Einstein's theory.
Yeah, but don't you see how fundamental that is?
Yeah.
All right, okay.
Okay, I appreciate it. Bye.
Good night. Thank you. This is KPFK Los Angeles. We are on the air live with Bruce DePalma as of January 29th, 1988, and we're going to take a short break, and we'll be back.
All right.
We're at a critical juncture. If Congress votes down aid this time, the decision may well be irrevocable.
Yeah.
If that happens, it's my great fear that we will have abandoned all hope for democracy in Nicaragua and peace in Central America.
2 historical days of debate in Congress on whether Contra aid will continue, and Pacifica Radio will be there live, gavel to gavel, with every member of Congress who wishes to speak expressing him or herself on Wednesday and Thursday, February 3rd and 4th. We'll have the issues behind the debate as well.
I spent 18 months in Nicaragua as a witness for...
And